Alright, so here we go. I've got some notes here for this week. This is Solution Stoichiometry, which is basically just stoichiometry where we add in molarity. So what you're going to need here, you're going to need a calculator, you're going to need a periodic table, you're going to need a writing utensil to copy down these notes that you're going to submit. And let's go ahead and get started. Remember, if you have any questions, you can email me. Otherwise, follow along and pause it if you need to. So let's see what we got. So zinc reacts with HCl to produce hydrogen gas and zinc chloride, ZnCl2. How many liters of a 1.50 molar HCl solution completely reacts with 5.32 grams of zinc? So we got zinc, which is a solid, Zn, HCl, which is aqueous, hydrogen, which is a gas, and zinc chloride, which is aqueous. So I'm going to rewrite this equation real quick just to be able to give myself some notes here. So that's zinc solid. And then we got the two hydrochloric acids, that's aqueous, HCl. That's going to give us hydrogen as a gas. And then zinc chloride, ZnCl2, which is also going to be aqueous. So let's write down all our information. How many liters of a 1.50 molar HCl? So usually molarity and volume I write above the equation, so I'm going to write that that's 1.50 molar, and I'm looking for liters, right? And then completely react with 5.32 grams of zinc. So grams and moles I usually write below the equation just like that. So we're trying to find this, right? So we know that molarity, here I'll do this over here, molarity is equal to moles divided by liters, right? Because I have molarity, I'm looking for liters. So if I solve this for liters, I'm going to multiply both sides by liters. That cancels out. So now I've got molarity times liters is equal to moles. I'm going to solve for the L, so I'm going to divide both sides by molarity. So that means liters is equal to moles divided by molarity. I have molarity, it's 1.50. I need to find moles. So I'm going to convert my grams of zinc to moles of zinc, and then moles of zinc to moles of HCl. So here's that work. I've got 5.32 grams of zinc. I'm going to use the T-chart. The molar mass of zinc, I look it up, and it is 65.41 grams per 1 mole. So I got 5.32 divided by 65.41. Very important. Do not round this number. If you got a fancy calculator, keep that value in there. If you don't, keep at least 5 actual numbers. Okay? So that's my moles of zinc. So now I'm going to convert my moles of zinc to moles of HCl. So I've got 0.0813 moles of zinc, and I'm going to convert that to HCl. I've got 2 HCl's right there for every 1 zinc. So I made this a little too big. So I'm going to take my value that's in my calculator and multiply by 2, and I get a value of 0.163 moles of HCl. That value, let me change my ink here. That value goes into here. So now I've got liters is equal to my moles, 0.163, divided by my molarity, which is 1.50. I found that up here, right there. So I got the value that's in my calculator divided by 1.5, and I get 0.108 liters. Let's make that 8 a little better there. 0.108 liters is my answer. So what does that mean? That means if I have 0.108 liters of 1.50 molar HCl, it will react with 5.32 grams of zinc. Let's try another one. So in this case, we have solution stoichiometry between two solutions. We're going to use the same chemical reaction. So let me bring that down here. That was the reaction between zinc and hydrochloric acid. So let's go ahead and write that one down here again. I'm going to give myself a little more room here. Zinc solid plus, I believe it was 2 hydrochloric acids, HCl's. That gives me hydrogen gas, I'm trying to write it in the same form here, plus zinc chloride, ZnCl2, and that was aqueous. Right? So what else do I need here? I've got, I think everything's balanced, right? 1 zinc, 2 H's, 2 H's, 2, yeah, okay. So it says, using the same chemical reaction above, how many liters of 0.500 molar zinc chloride, so this is 0.500 molar, and I'm looking for liters, again I write that above, can be produced if 0.225 liters, so there's my HCl, 0.225 liters, of a 0.200 molar HCl solution is used. Okay, so I'm trying to make 0.500 molar solution. I want to know how many liters of that I can make if I use all of this HCl. So let me change my color here. So let's look at this right here, right? I'm looking for liters. I've got molarity. I know that molarity is equal to moles divided by liters. So then that's liters times molarity is equal to moles. So that's liters equal to moles divided by molarity. That's how you're going to find liters. I need molarity, which I have, 0.500, and I need moles. I'm going to get the moles by using stoichiometry. So over here, I've got molarity, and that's of the HCl, is equal to moles divided by liters. Excuse me while I take a bit of a coffee break. I apologize. So let's backtrack. I've got molarity of HCl. That's going to be moles divided by liters. If I rearrange this, molarity of HCl times liters is equal to moles of HCl, I can easily find the moles of HCl. So that's another way to find moles. So that's going to be my molarity, which is 0.200, times my liters, which is 0.225, and that's going to give me my moles of HCl. So I get a value of 0.045 moles of HCl. Great. Now I got to use stoichiometry to convert my moles of HCl to moles of zinc chloride. So I've got 0.045 moles of HCl. I'm going to use the good old T-chart. I'm going to go to ZnCl2. I'm going to get rid of HCl, and there's a 2 in front of that HCl. So I'm going to basically divide my value in half, which I get 0.0225 moles of ZnCl2. That goes right there. So now I can figure out how much, or I can figure out the liters, how much volume I'm going to get. So I've got my moles of 0.0225. I'm going to divide that by the molarity of 0.500. And from that, I'll get the liters. That gives me 0.045 liters. And that is how much zinc chloride I will make if I'm shooting for 0.500 molar. Okay. One last problem here. Oops, there it went. Ooh, slow down. Slow down, fella. So this is going to be using solution stoichiometry and then just a refresher of gas laws. Okay, because we don't want you to forget all that stuff. It's really important that you're getting all this information down. So, said acid rain results from the reaction of nitrogen dioxide with water in the air. At STP, let me refresh your memory here. STP is 1 atmosphere and 273 Kelvin, 0 degrees Celsius. How many liters of NO2 gas are required to produce 0.275 liters of 0.4 molar HNO3? Let's rewrite the reaction here, give ourselves a little bit of room. So we got 3 NO2 as a gas plus H2O as a liquid. That goes to form 2 HNO3, which is aqueous, plus NO as a gas. Okay, so what do we know here? We're looking for liters of NO2 gas. So I'm looking for that. We have 0.275 liters of 0.4 molar HNO3. Okay, so I'm going to use this HNO3 to make NO2. Well, we're told STP, this is a gas, so since that's a gas, we can use PV equals nRT. We're looking for volume, so it's V is equal to nRT over P. Right? Pressure, we know what that is. That's 1 atmosphere. Temperature is 273 Kelvin. We know what R is. We just got to find moles. Okay? So right here, I got molarity is equal to moles divided by liters. Molarity times liters is equal to moles. And so we've got molarity, which is 0.400, times my liters, which is 0.275, is equal to moles. What do we get for that? Remember, don't round until the very end. So this ends up being 0.11 moles. That's how much HNO3 I have. Now I have to convert that to NO2. So I'm going to do that in red, I think. So I've got 0.11 moles of HNO3, and I'm going to convert that to NO2. So HNO3 goes on bottom, NO2 goes on top, and there are 2 HNO3s for every 3 NO2. So it's going to be times 3 divided by 2, which I end up with a value of 0.165 moles of NO2. So there's my moles. That value goes right there. So let's plug everything in. I'm going to use green for this. My moles, we said, was 0.165. That's how we got that value. R is 0.0821. That's the constant. Temperature is 273. And our pressure is 1 atmosphere. And that's going to be our volume. So let's see what we get. 0.165 times 0.0821 times 273 divided by 1 is 3.698. If I round, let's round that to 3 decimal places. So 3.698, and that's liters. And so there's an example of solution stoichiometry and gas laws. So there you go. 3 examples. Match up your example with the problem that you're trying to do, and I think you'll be in great shape.